background. Sorry about that. I was testing the background. Welcome to Land Tamer Stream. Good to have everyone tonight. We are doing some more BDP, bandwidth delay product, which correlates to TCP window sizing. And today we're going to be playing a little bit with Azure and the Azure CLI and NSGs in Azure network security groups, which is kind of like a firewall. So a couple things. And, I just want to acknowledge too, well, this, of course, we'll start with our wallpaper of the day, man. This is beautiful. This is what I meant to show yesterday, but I've not changed it yet. But this is called, I think, Green or something. It's a galaxy on this Flickr site that you all know that I follow here. My windows got rearranged. Here we go. Yeah, I was playing some music before. For people who are new to the stream, I tend to fire up the stream a little early. I try to start every night at 7 p.m. Eastern, just for consistency. Usually I've been, learning or labbing a little bit before then, but I'll fire up the stream, just do a few checks. And so the Twitch stream actually starts usually between 10 and 5 minutes before. Yeah, I saw, actually, mentors, I'm going to use some of your links that you sent me earlier, which are really good, and I posted them here. These are some links that we'll be referring to when we're talking about tuning the receive window, the TCP receive window in Windows operating systems. So we'll be referring to these a little earlier and kind of testing those out a little bit. But yeah, this is from Judy Schmidt on Flickr. She takes a lot of the Hubble photographs and discoveries and composes or puts those together. So cool stuff. But yeah, let's talk bandwidth delay products. So yesterday I spent all the time, and we figured out the formula. I know what the formula is. I know how to calculate the formula, but I don't necessarily know exactly what it means or the implications of the numbers in the formula. So I felt like I really needed to do a little bit of labbing on this. I call it labbing. We're just going to be doing some iperf. We're going to be doing some Wireshark. And I did some locally, but I had a few issues with here locally because this is a Mac, and I'll get into it, but this is a Mac, and I was trying to hit a Windows box, and I was having some issues with the iperf in Windows. Shocker. But I decided, we'll do some iperf testing. We'll play with the receive window size, and we'll have, one side will be client here locally on this Mac, and we'll set up a server, iperf on a server in Azure. So, because in Azure we can put whatever we want. We can spin up whatever we want, right? There are no hardware limitations, no OS limitations, etc. So, one thing we do have to do, or will have to do though, is modify the firewall, because I've got a server out there now with a public IP that I use for testing out some things. Yeah, fun to play. It's fun to play in Azure. I've been enjoying playing with cloud stuff, so I'm really starting to get ramped up on Cloud 2 at my job, so getting more involved with the solutions that we have there already in cloud, and getting a lot more involved with that, getting involved with automation. So I'm excited, and I'm going to be sharing more of that as I learn, right? But yeah, so talking about the bandwidth delay product, TCP window size, this is very important, and it's significant, especially when you're having some sort of delay or latency, or you're not getting the throughput. For example, let's say you have 10 gig connections in your data center, and you have two different applications that are doing transfers of large files, but one of the applications seems to be running just fine. You're getting pretty significant throughput, but another application, the operating system is not being taxed, the memory is not being taxed, the RAM, any of the resources, maybe you're at 2% utilization on CPU on that box, and it could be on the same, VMware host, for example, same subnet, and it is getting very poor performance. Well, this is where TCP window size might come to play, and being able to monitor it. So as I mentioned yesterday, iperf is a free, very basic tool. It is useful, I think, in a lot of cases, but in general, in an enterprise or a service provider level, you're going to want to have more you know, high-powered tools where you can, in real time and historically, see what your do an analysis of TCP statistics, including receive window. And for example, where I work, we have that kind of, it's not free, and we have a number of different solutions that do that. But in particular, our ops folks use some tools where they can at any time pretty much look at current and historical TCP window sizes and begin to do some analysis. So that's what we want to try to do today and really understand these formulas a little better. So we start out by doing iperf 3 on the Mac, installing this on the Mac. And I fumbled at that yesterday, and I found out today all you really have to do is do brew, which I really like. So I've already done that. And yeah, I think it's just brew install iperf 3, and it should say it's already there. Brew, if you're not auto-updated brew, yeah, updated 1 tab. Okay. It's already installed and up to date, so we could, of course, reinstall it. But now we've got iperf installed. And as we can see here, there are a number of options. I had an issue using the window size as a server on a Windows machine I have sitting over here. And I'm not sure why, but it didn't like when I specified the window size. So by default, I think it's 8 kilobits is a window size. Let's see. I'll go ahead and turn it on. Okay, it's running over here on a, hey, DeBizzle, good to see you, my friend. Hope you're having a great Wednesday, hump day. Hope your studies have been going well. Okay, yeah, iperf is running over there. We're doing a little iperf, playing with some throughput and measuring bandwidth delay product and TCP windows receive size. So, study, what's that? Huh. Yeah, I know, right? Sometimes it seems like it's hard to get in the time, man. But yeah, what I did over there is I ran iperf 3 /s, which is server mode. So on this side, what we're going to do is, where is my, I think it's iperf 3 /c, and then we specify the server. And I think right now it's 10.1.9.110. So this I can do locally. And it's going to give me some stats here, right? And I think by default in the older versions of iperf 3, it would actually tell you the window size as some of the statistics. Let me see if we have the options here. Get server output, UDP counters, repeating payload. Set window size. That's what I tried to do on this Windows box over here, and it didn't work. Bitrate, UDP, authorized users. Let's try verbose, and we're also going to do, we're going to run Wireshark as well on this client machine. And we should be able to see the statistics, right? I think it's, yeah, TCP port 5201 is what it uses by default. So let's do verbose. Oh, it doesn't like that. -V. Oh, that's version. Uppercase V. Okay. Hey, it uses a cookie. Interesting. TCP port. Yeah, 5201 is the, oh, did I start it? No, I did not. Sorry. That is basically showing everything. TCP port. All right, let's try this again. There we go. So as you can see, when you're looking at the window size, we have the information here in the header or in the info. And it's interesting here because we already see a reset. Maybe that means it's done. I'm not sure. So is this in order? Let's see. Boy, it sent a lot, didn't it? You'd assume that if you use a much larger window size that you would not, obviously would not have as many. Okay, here's send.ac. Okay. And on the send.ac, it should be in every acknowledgement, right? 65535. I think that, okay, window size value 65535. Calculated window size. Okay. And then options, under TCP options, maximum segment size, window scale of 2 multiplied by 4. Okay. This is important, especially in the article. There's an article I just posted in the chat where you can adjust the scaling factor. I think this is by default. In fact, let's go to that article. I think it's this first one right here. This is from just a few months ago. Yeah, word about auto-tuning level, TCP receive window. So I remember, and someone, I asked this on Twitter, and I got one response just a little while ago, actually, from someone who said that, let me read it. I know I'm jumping around here a little bit, but we do have a plan here. We're getting to a goal. But yeah, I asked, who has had to adjust or use the BDP and adjust their TCP receive window size in production or as part of your design? And so far, I've only gotten one answer. And let me see if I can find it here. Yeah, Jasper, he was like, used it years ago when XP was still the normal business OS to demonstrate to a customer that 1, his window size maximum wasn't large enough for his WAN link, and 2, the same OS but for too large of a window size in a case of buffer bloat. Some people, he probably meant buffer bloat, killing speeds with retransmissions. Yeah. So I have seen this before. In Windows XP as well. I remember a customer years ago that was deploying Windows XP. Well, they were transitioning their connectivity to use layer 2 tunnel links between some remote sites. And we had a big issue with workstations. They were using terminal server or remote desktop services now, I think it's called. And they were connecting into these terminal servers using Windows XP machines, and they had some thin client desktops as well. But what was happening is they had a really large group policy. So, when Windows, you log in, and one of the first things it wants to do when you authenticate is read the group policy from the server that is, you're authenticating to. And sometimes a group policy would be very large, and there would be issues with that. So we had to do a couple of things to let the Windows XP workstations know. One, there's some registry settings. You could tell it to not wait to log in before you get a copy of the group policy. So we did that. That helped, but we still had random disconnects, and it was not a bandwidth issue. Like, we were monitoring the bandwidth, and it turned out that the maximum, we had to actually adjust the MTU. It probably wasn't, in hindsight, the correct setting. Probably something more like this would have resolved the issue, but we found when in the registry, we lowered the MTU. That resolved most of the disconnect issues, and I think it was related. XP had some TCP/IP stack problems. Let's just put it that way. So I could definitely see this kind of issue. Supposedly in later versions of the operating systems, they have really improved the scaling of the window size, and as you can see in here, I don't know that you can necessarily set a fixed window size, but you can change the sliding window factor, the scale factor. So there are different settings in here, and it's summarized here. Normal is a scale factor of 8, and I think this is Windows 10. Restricted is scale factor of 4, highly restricted scale factor of 2. So this is interesting. In the machine I'm hitting, I think, is Windows 7. And it looks like it is using a scale factor of 2, right? Or 4. Where did that go? Oh no, window size scaling factor of 32. Mentor says, yes, early XP, SP1, and earlier by SP3. Yeah, we did see a lot of problems with SP3 with the networking stack. That is true. I do recall that as well. So you do have to get into looking at operating systems sometimes, even if you're doing it, if you're a network engineer, right? You know how operating systems work, you know how the stacks work on your operating systems and what some issues might potentially be. But this is 32, and where did my article just go? Did I close it? I'm bad about that. Here we go. 32. Maybe that's because we're running iperf? TCP payload and the data. Window size scaling factor is 32. And here's the value, 4117. Is that 4117 times 32? It is, isn't it? Okay, it is. So the window size value is 4117, and with a scaling factor of 32. So it could go up to, basically that's our range, right? 4117 is really small though. Because remember, that is, if we were to plug that into our formula that we had yesterday, 312500, that's kind of close to this, but it's even 3 times greater. Interesting. Okay. So anyway, that's what iperf is telling us. That is with a default window size of 8 kilobytes, which is the default for iperf on Windows. So now what we're going to do, folks, is let's see. First, I want to look into some of the statistics that we get. Yeah, your Windows 7 x86. Yeah, I would expect a Windows 10 machine to be much different. So let's look at an IO graph here. And it is calculating that. Actually, let's do it. Let's close this. We'll stop. Where are our TCP? Here we go. TCP string graphs. Window scaling. So notice that Wireshark has a window scaling statistics module here. So obviously this is something important, right? And I guess it is building it. Okay, yeah, here we go. Okay, so click to select packet. Zooms. Receive window in, bytes out. Okay, here we go. Oh, and interesting, as I'm clicking, check it out. As I click on here, it jumps to those packets. That's cool. I didn't know that. That's where we had a reset. So window size in bytes, it's saying 0, isn't it? Yeah, this is our time scale here. Let's do... Oh, here's our receive window. Okay. All right, so if we zoom in here a little bit, bytes out. All right. It's pretty consistent, isn't it? So it did not change much. Only like right at the beginning we had a little bit of variation, but other than that, it's pretty consistent. All right, let's try to pound it. Let's close this. Start the capture again, and this time let's send a much larger payload. Number of bytes to transmit. CPU utilization, local sender. Okay, remote receiver. All right. 93.4 megabits per second. Guys, these are gig. Well, one of them may be 100 megabits per second link, to be honest. I need to take a math lab course and improve my math skills. Tell me about it, man. This is some mathematics here. Transfer 11 megabytes. Okay. So in 10 seconds, I sent about, in 10 seconds, I sent 109 megabytes at a bit rate of 91.4 megabits per second. So let's increase. Let's see how much it takes to break it. Server or client port, format interval, file name, bind. Verbose, debug, server, client, UDP, connect, bit rate, target bit rate in bits per second. Default is 1 megabits per second for UDP, unlimited for TCP. Okay. Set the timing for pacing in microseconds. Okay, let's reduce this. The default is 1000. So let's set the pacing at 10 milliseconds. 999 will break if my hunch is correct. You mean the mentors? You talking about the pacing timer or the bytes? Number of bytes to transmit. By default, it looks like it's sending about 10 megabytes. Bytes, yeah. Okay, let's try. Let's see what is the default here. Let's break some stuff. It's fun to break stuff, right? Oh, it's either number of seconds or bytes. Or blocks. Okay, so we're going to just say Why don't we keep all the defaults except for the pacing timer? So it's going to send it very quickly. Or it's going to try to. And I would think the reaction would be that it's going to have to reduce the window size. Okay, it looked like it handled that fine. This interval was 1, this interval was 1. Okay, that didn't change anything. So let's just up the number of... bit rate, target bit rate. All right, I'm going to check something real quick, guys. I'm going to check to see on networklessons.com. I won't be showing this on the screen here, but there was an exercise in there where, oh, no buffers. Let's see. There was an exercise in here where it kind of demonstrated the okay, our throughput is increasing. It doesn't double anymore, but it's better. Let's double the window size. Okay. Yeah, what that was demonstrating is the throughput. So I think what we're going to have to do is just really reduce the window size on the server, which I'm going to need to do with the Azure box. So let's go ahead and transition to the Azure server that I have. And I'm going to show that to you guys. So I don't know how familiar any of you are with Azure, but of course you have a portal. And all you have to do is do AZ login. Once you have the Azure client, Azure CLI client installed, then you select your account. Basically, when you click when you type in AZ space login, it will launch a browser and then ask you to select, or you're not using a Docker container for Azure. No, I actually installed the Azure CLI client on my Mac because I'm going to be using it a lot. So my client connects directly, and what it does is it launches the portal, and then it just goes to basic CLI page. All right. So now I can access my resources. I can actually go to So I'm here in the portal, and I don't remember all the details here, but I know that this is my machine. Okay, LTSU PD1 netbox 1. And I have it stopped. So I'm going to start the virtual machine, but I want to figure out how to do this command with the Azure. So it's AZ VM. As you can see, it's pretty easy to use. AZ VM start. And I have to specify the name. A lot of times with these commands, okay, resource group and name or IDS are required. Resource ID. So what I need here is the resource group. Just about every command you do with Azure, you need to know the resource group, which I'm just going to copy it here. And the server name. Which is here. I have to say, yeah, resource group. Oops. And name. And that should start the virtual machine. We're going to try to do as much as we can. I'm learning too, folks. This is kind of new for me, but I'm trying to decrease my dependency on the portal, the web portal, and learn to do as much as I can in the Azure CLI. Now, this virtual machine is Ubuntu 16.04 LTS, long-term support. And once it's running, yeah, I'm glad to help, man. Actually, my first GitHub repository is some notes and a script that I use to deploy this virtual machine. I actually deployed it from the Azure CLI. So, all right, so that is getting it running. All we have to do is a refresh here. And we can see it is now running. And this is a public IP, which I have restricted, right? So what the next thing we need to do is I need to open up this ports. I already have SSH available, so let me see if I can get to that now. You can also in Azure, you can actually look at your console. This says preview. I'm not sure if this is actually working. Okay, it is. Not just yet. Connecting the console. So you can do that kind of thing, but since I've allowed SSH already on this device, then I can just log in. And I'm going to log in at, get that IP again. Copy that to my other window over here. Okay, now what did I use for this password? That's what I have to find. One moment. Netbox. Go to my password vault program here. And we're in. That's all there's to it. So I'm now SSH'd in. And I'm assuming that this is, by the way, that just, the Azure CLI brought me back to the prompt because it just finished the command of starting the virtual machine, right? So now what we need to do is we want to allow iperf. First of all, what we need to do is we need to install I'm gonna outline these steps in case anyone wants to review this later. But so we're gonna say install iperf on the Mac, start up VM in Azure, install iperf 3 on Ubuntu VM in Azure, and I think all I need here is apt install iperf 3. Oh, sudo apt install iperf. Resource temporarily unavailable. It's another process using it. Maybe it's still booting. We'll give it a minute. I just run the update the other day, and it's saying 33 packages can be updated. is another process using it. Interesting. So we're going to install iperf 3 on Ubuntu VM in Azure. Then we're going to use Azure CLI to add iperf port to NSG. That's kind of our firewall, right? Because right now I only have, I think, just SSH, maybe HTTP, HTTPS allowed. But in order to do that, if we go to the security tab, oh, actually, no, that's the security center. I think we have to go to networking. Yeah. So right now I need to add another port here. And this is the name of the network security group. And we're going to go ahead and do that step while we're waiting on whatever's going on with the VM. So AZ, I think it's going to be okay, AZ network. NSG. AZ network NSG update. Okay, it requires a resource group in the name. As you see there again, we have to specify the resource group, which is generally always listed at this spot for any object that you're working on in Azure. And we're going to say name of the NSG. We already have that. Well, I think I did have it. LTSCUPD 1 netbox 1 NSG. And then we're going to add, and I'm going to have to reference this, Azure NSG, Azure CLI NSG. There's so many ways to do this, folks. You can use Azure CLI. You can open Cloud Shell in your browser. You can select a Cloud Shell here, and it'll launch a little shell for you inside of Azure. So many ways to do it. Create security rules. The following creates a rule allows traffic inbound from the internet from application security group over port 22. Okay. Hey, show IP interface brief is in the house. How's it going, man? Doing a little Azure CLI stuff. Okay, so what I need to do is I'm going to modify this. And we know the name of our... See, it's easy to do really quickly, like in the portal. But I'm taking a little extra time just to learn this. All right, so our resource group is this. The name of our NSG is this. And we're going to say allow, the name of the rule is allow iperf 3. Access allow protocol TCP inbound, and we're going to do 5201 is the port that we're using. Source address prefix. Actually, let's list out the rules. List. There we go. Okay, source address prefix, right. That's a nice thing, is when you're using Azure CLI, wow, busy. Yeah, man. I'm trying to learn, support range. I'm trying to learn the significance of the bandwidth delay product and the TCP receive window. Like, I know the formula. Okay, here's the, oh, that's priority. We'll put priority 1, sorry. 5201 is the port range. Source port range, destination, application security groups. I'm not using application security groups right now. So we're going to put null here. Actually, I'm just going to take that out. Okay, and I think this will create our rule here. Allow iperf 3, access allow, protocol TCP, inbound, priority 1, source edge. Okay, priority 1 just adds it to the top of the list. You all have edited firewall rules before. You know how that works. All right, so we're going to put this in the Azure CLI. I don't think it... Oh, it wants 100. Okay, fine. I'm going to do that. I think that's what we need. Security rule, remote office TCP conflicts with rule allow iperf 3. Rules can have the same priority and direction. Ah, okay. Fine. Uh, 120, 110, 100. All right, we'll do 105. How's that? How is that, Azure? Are you going to be happy? Running. All right. So let's see. While that's running, things, by the way, in Azure, when you're provisioning, they're not lightning fast. Like the CLI you'd expect, you know. That has been my finding anyway. Okay, iperf 3 is now allowed. Sweet. So now let's see if we can install it. There we go. Yes. This, by the way, guys, I use a very low-tier server for my NetBox installation. So I am using, it should say in the overview here. I am using like the cheapest virtual machine I could get away with. The cheapest virtual machine size. So it's still highlighted on network security group. Let me go back to here. Oh yeah, sorry. Yeah, this is basic A1, 1 vCPU, 1.75 gig of RAM. This is a very low-end VM, guys and gals. Because I wanted to do cheap, and amazingly enough, it works pretty well. Like, you know, I was browsing it the other day, running my, I think I created a, maybe I didn't. But the NetBox app I have running on here is Okay, did I move it to HTTP? Yeah, I haven't moved to HTTPS yet. Yeah. It ran pretty well. So, but yeah, that's now we've got iperf 3 installed. Now we're going to turn it into an iperf 3 server. So now we can play with the window size. Now we can try to break it a little bit. Mentors ask, when you say cheap and affordable, would you say more expensive than the Google Cloud deal with $300 credit? Google Cloud would be a better deal. So what I would encourage people to do is to learn. I would try to learn, you know, Azure. I would try to learn Google Cloud. I would try to learn AWS to do some of the basics. They all have options that are free for a while. So in this case, I'm really trying to learn. Azure is my highest priority to learn, and I will be learning it in 2 months. I guarantee you, folks, because I'm going to be working on a lot of automation in my job these days. You know, I'm going to be doing a lot of sort of cloud engineering in Azure. So we're going to be using Ansible. We're going to be doing deployments, automated deployments. We're going to be doing scripting. Probably be using more PowerShell than Azure CLI. If it were up to me, it would be more Azure CLI, but it kind of depends. So I'll be doing a lot of that stuff. So these, I should be a lot more proficient with these commands in a few months. But the thing about running something like Netbox is, one, you don't need nested virtualization. You can do nested virtualization in Azure, but you have to buy a big machine. And Azure charges you, and most of the other cloud providers too, they charge you for compute and memory while you're using them. So when you turn the virtual machine off, you're not charged. You are charged for storage continually. As long as you have something stored out there, like a virtual machine hard drive, you're going to be charged continuously for that. And Azure charges you, I think, by the hour. Google, one advantage to Google Cloud or G Cloud is they charge you by the second. So instead of charging you like a full hour for running a virtual machine, the compute and the RAM, they'll charge you just for the seconds that it is used, that is started up, and you know, until it's shut down. So in Azure, you can set policies. I know you can in Google Cloud too, to where you automatically, let's say you forget, like mine is scheduled to shut down. If I forget to shut it down when I'm done, I have a policy set to automatically turn it off at a certain hour. You know, so. But with this Netbox solution that I was trying, it's a very, very small virtual machine. Like it's one of the low end, as a very low end, you know, processor platform. So it'll be very cheap to run. I could run this Netbox in Azure with the $200 credit for who knows how long. But if I want to do nested virtualization, Google Cloud is definitely the way to go. Good question, though. Very good question. All right, so we have iperf installed. And now what we want to do is play with this a little bit. Let's try our defaults and just kind of verify that this is working, right? Oh, I think it's iperf 3. Okay, server's listening on 5201. That's Azure CLI. Did I have another? No, I didn't. Okay, iperf 3C. And we're going to hit the... we are going to reset this Wireshark too. And let me hit this machine. If I can remember the... Shoot, I closed my Azure window, didn't I? No, I didn't. Okay, here's the IP. Hey, we got a connection. Check it out. All right, obviously this is a lot smaller size than what we had on our local LAN, right? Which we would expect. So let's go ahead and take a look at what we found in Wireshark. All right, so our window is a lot smaller, 28,960 as opposed to 300 and something thousand. So we're looking at about, 9 times smaller window. Okay. And do we have any resets or anything? Okay, we've got a few retransmissions out of order. So, this is going over the internet. So we would expect something like, things are about to get exciting real soon. This journey is getting fun. It is, man. I'm having so much fun doing this stuff. I'm having a lot of fun. So let's look at our TCP statistics now again. Our window scaling. And let's do, where's the yellow line is what we're looking for, right? It's supposed to be... Oh, look at this. TCP window update. Window size value 9887, 9910. So we see TCP working here, right? All right, there's a lot of window updates. 8894, 8916. So it's going up. It's adjusting, which is good. That's what TCP is supposed to do. It tries to ramp up. After there's a reset, everything's working fine here. We got our acknowledgments coming back. And right here, the window size is interesting. So it's changing, right? 86, 4,000, 86, 4,000. It's like 8,000, 4,000, 8,000, 4,000. And then we see it a little more consistent. It's sending the Windows update. Sent quite a few. 9,000, 4,000, 9,000, 4,000, 9,000, 4,000. 10,000. So that's what TCP is supposed to do, right? It's supposed to change based on the networking conditions. Over here, it's up to like 11,000, right? I'm not sure why we're not seeing it on the graph, though. Oh, we're not zoomed in far enough, maybe? Oh, there it is. All right. Found you. I don't know. This looks like the last graph, doesn't it? Switch direction. Oh, here we go. Okay. This is what we're looking for. To save some Wireshark and do a side by side. Yeah, I want to save this one for sure. Good point. So this is the default, which I believe if we look on the server itself, yeah, I believe the default is 8 kilobits per second. All right, this is pretty cool though. So it went up and then down, up, 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 down, down, down. All right, window scaling for this. And here's the bytes out. Interesting. So it went up to here, and then we had a pause, or it went down again. This, see, this is an interesting graph, right? Because a lot of problems with TCP, and this is why the red is important. Random early detection with TCP, and if we had multiple streams going to this host, we'd probably see them all drop and go back down to 0 at the same time, which is called global synchronization, right? Which you really don't want. So this is cool. All right, so I'm going to take a screenshot of this. Possibly our resets on the graph. Yeah, those probably, as a matter of fact, good point, mentors. If we click here, yes. That one's in yellow, TCP out of order. If we do this side by side here, yeah. So we got a lot of TCP retransmissions here. So it looks like it's saying, all right, let's see how fast we can go. It goes up and up and up and up and up and up until it drops. Let's see how much we can take, right? And then we see a sort of normalizing here. And it looks like when it gets out to like 3, 4, 5 seconds out, it really gets a good rhythm going here with this window size of about how much? Yeah, it's alternating between 4 and 8 here, I think. That's kind of cool. So it knows, I need to send 4, 4, 4, 4. He's saying you could go higher, 15, 2, 6, 7. And it looks like they've figured out that we'll be much steadier at just 4 of a window size of 4. Interesting. All right. All right, so we did that one. Now let's increase. Let's try to get some more throughput. We will save this. Export. Oh, what am I doing here? TCP. File. So the auto idle is like when we are booting up a VM. Seems that way. All right, I want to select all these. Oh, I have to stop it. That's why. Like, why can't I save it? Export specified packets. Let's see. We want to mark them first, right? Mark all displayed. Export specified packets. Uh, 822.2.0. This is going to be iperf default window size. And we're just going to export the displayed. Okay. So let's start it up again. And this time we're going to change the window size. We found our threshold is about 5 seconds at how many bits? It's actually 10 seconds, I think. Yeah, so from 0 to 10 seconds, the sender sent about 5 megabytes at 4.16 megabits per second. That's okay, but I should have better upload speed than that, all right? So I'm going to increase the window to, instead of 8, we'll go, let me look at an example. We'll double it. K, M, or G. Okay. K. KMG indicates option to support a KMG suffix for kilomega. Yeah, man, good old Wireshark. Love it. All right, this is the same issue I had on Windows. So when we do window size, KMG, set window size, socket buffer size. What am I doing wrong here? Yeah, I guess, you know, the documentation is not that great, I found. Command line option, a letter specifying the format to print bandwidth numbers in. I looked at this earlier and it didn't really tell me what I needed. Set the socket buffer to specified value. This gets sent to the server and used on that side too. /W N number and K or M, right? They don't really have examples. Notice this is the BDP formula right here. Does it have to be lowercase? Okay, here's an example. -W space K indicates support a K. Okay, why doesn't it like it? That shows 8KB. Oh man, this is frustrating. Come on. There's a BDP formula. I'm finding that everywhere. Let's change the search dates. This command will work when W set to for anything higher in error displayed. Oh, I did a little poking and thought I was there. Yeah, the documentation is not consistent. No, it's not at all. Meraki. Lowercase r will not work. Oh, hyphen W 2000. Let's try that. Does not work. Man. Well, that's a client. Okay, here's our next. Yes, we do. We have a new topic to explore. Maybe I have to do this on the client end. Maybe that's the problem. So let's do that, and then let's come over here to the client and say, aha, there we go. So it actually sent less. So let's bump that up. I was thinking it was 8. Maybe it's 8,000. Yeah, now we're cooking gas, buddy. Let's see. Let's go up a little bit. Let's say that was 16. Let's do 32. No, let's go way up. We'll keep going until we break it. 2 megabits per second. Okay, so we see that is helping. The sender 4.16 was the best. So let's keep going up. Okay, I think now we're kind of pushing the limit. It went to 4.31 and then it dropped. Let's go. That'd be 1 megabit per second, right? Okay, 10 megabits per second. Okay, yeah. So, wow. All right, let's do that one again. That one's an interesting one. And let's pull up Wireshark. And let's do this. So many windows. All right. Yeah, it's not really changing the window size on the receiver. I don't think. Yeah, that's just the sender. But the sender is not expecting any data back. So I really need to set it on the server. Yeah, as a matter of fact, my example that I have from the network lessons is configured on the server. That's really where we need to configure it. And what do we do here? 1000 KB. It doesn't like it. That's unfortunate. Yeah, I think the network lessons example I have is using an older version of iperf. Let's try that. Let's try to install the old one. Sudo apt install iperf. Yeah, let's just run the old one. iperf s. Hey, now we're talking. Oh, different port. Shoot. Okay, well, let me open. And I did not save that, did I? Nope. Okay, more practice. We did. What was it? 5001? Yeah. And we're going to change this priority. And the name, let's say 115. I'm going to call this allow iperf. Sweet. And it did it. Yeah, I didn't have to retype all that stuff. It's awesome. Okay, so now we have a larger window size. Let's clear this. Trial and error, buddy, back to old school. You know it, man. Younger peeps take notes what old salty geeks do for fun. Yeah, man, I like that, salty geeks. That might be our next emote, mentors. Salty geeks. Love it. All right, so boom. It probably wants me to install, brew, install. Look at that. It's like, no way, Jose. Oh, because he's sending to port a different port. So let's do brew install iperf. Yeah, there we go. Okay. iperf. See. All right, it says it's connected. TCP window size 128 kilobytes. All right, now we're in business. Okay, different output here. 10 seconds, 2.75 megabytes, 2.25 megabits per second. Okay, so now we're going to bump it up. That's the default. This is going to be similar to what we saw before, right? Yeah. Look at the window, 131360. That's actually a little larger than what we were seeing earlier. Let's do our graph. Huh, that's interesting. Okay, that's the one we want. Yeah. Okay, so the ramp up was pretty quick. It ramped up like really quick, and it stayed around this area. So that's a lot more data. Obviously, we increased the size. So let's go back and try this again. I'm going to save this. See if we can figure out this save again. Mark all displayed. Stop. Export specified packets. All displayed. I didn't have to mark them. And we're going to say this is, what was our window size here? Okay, 1600. Or 16,000. Which is double the default, right? Well, we'll see. We're going to go ahead and increase it now. Start new. And we're going to do 32. Warning, requested 31.2 kilobytes. TCP window size, yeah. So that's a significantly larger window size. Send ACK. The ACK should have 28960. Okay, 2.22. It's about the same, huh? I think that we're reaching sort of our maximum throughput, right? I'm probably hosing the stream too. I didn't think about that. This is going over the internet. So let's make this smaller and try it again. Don't forget a graph pick. Yeah, I'll do that here in a second. Okay, finished. Now it went way down. 1.16 megabits per second. All right. Let's drop it down even further. Interrupt again to force quit. Okay. Now let's do a much smaller window size. And see what our throughput is. Oh, shoot, wait. Let's restart. There we go. .95 kilobytes. And it's done. 934 kilobits per second. All right, so this is much lower, right? I think we started out kind of high, and we weren't really able to get much more, squeeze much more out of that connection, because that's just the limits of, you know, I don't have the best bandwidth. But let's look at our statistics now. Interesting. So this is something else we see. I'm thinking, like, if I was teaching a class right now, I'd say, what problem do you see with this? And essentially what you're seeing is a lot of unused bandwidth, right? So it sends, and this is what you would see if you need to adjust your TCP receive size if it's too small. Because this is what you'll see, right? You'll see it's sending what it can, and then the receive window is basically too small and it's not allowing it to send more, so your throughput is much lower than what your bandwidth is. And this is the kind of problem you would want to, that the BDP and adjusting the TCP receive window is going to help you solve, right? Because this is a lot of unused bandwidth. Look at these time intervals. Whereas on the other graph, remember, of course, this is local network, but we see the idea, and that is there's not a lot of delay here. Like we're hitting an upper limit, and then we're leveling out, and we don't have send, wait, send, wait, send, wait, send, wait, right? So that's cool. I think it would be easier to sort of test it on a local network where you're pushing the envelope, right? Let's take a screenshot of that. So that's cool. Let's say we adjusted it up a little more. And let's go with, let's double that. It hasn't finished yet, so. This seems to be a much more steady stream. $1,400. Yeah, that's much better throughput. And we don't have this effect where it's sending, waiting, sending, waiting, sending, waiting. It's not happening. Cool. Well, that was a good exercise, I think. Yeah, 1.12 megabits per second. It wasn't much higher. However, yeah, I think it's enough to illustrate the point, though. Still at it. I had to step away. Yeah, man, still at it. About to wrap up, though, I think. It was a good exercise. I think I understand better how to use Wireshark to sort of, oh, look at this TCP window full. See, even though we increased it a little larger, we did get a TCP window full message. And that was from the client, though. Interesting. Well, I think that was a good exercise to run. I'm going to shut down my virtual machine now. Already Azure, shoot. Yeah, we'll do a VM stop. And, these were our steps. It looks to me, you said it well, mentors, this is a lot of trial and error. So, I think you sort of start out, if you're trying to maximize throughput, right? You start out with the BDP and you try to use that to figure out what your ideal receive window is going to be. But just realizing that there's a scaling factor there and that the TCP stack, the TCP will make adjustments over time. And as a matter of fact, with the operating systems now, it seems that with like Windows 10, you can change the scaling, the sliding scale factor, but you can't really hard set the receive window like you do with iperf. The operating system wants to calculate that based on the size of your, speed of your NIC and other factors. And that's what this article talks about. It seemed like with Windows XP, you could set a fixed window size, and you can't, as it's saying, you can do some tuning, but the tuning you're doing is the level. So you've got disabled, fix the receive window at its default value. You can't fix it at its default value. You can do highly restricted, allow the receive window to grow beyond its default value, but do so very conservatively. You got restricted, allow the receive window to grow beyond its default value, but limit such growth in some scenarios. A normal, allow it to grow to accommodate almost all scenarios. And then experimental, allow the receive window to grow to accommodate extreme scenarios. You can do this at the command line using netshow. And then awesome, but how can we confirm that it's actually working? And it says network captures, right? TCP captures, Wireshark, or TCP dump, something like that. So this is really great for, WAN connections and even your data center. And I think I have a better concept now of this formula and how it works. I'm going to play with it a little more probably tonight, but that was fun to lab. Looks like our virtual machine is stopped. I think we can query let's see, Azure AZ VM. I think I can actually do that, and it will look at my subscription. Wow, it gives me a lot of information there. But I think we're good there. According to the portal, stopped. Still incurring compute charges. Interesting. Okay. Let's see if that's still the case. All right, I don't think it's completely stopped. Because when I came in here earlier, this was not, it did not say still incurring compute charges. Let me look at my charges so far. Yeah, I don't think it tells you anything because it's in trial mode. I'd really like to see, though, what the costs are. You can enable cost management. It's not enabled currently. All right. Yeah, they do. What it does say, though, if you do a free trial, like at my company, we have a very detailed billing. It's turned on, and we can see, all the details you want to see about your costs. I heard on a podcast, I think it was Packet Pushers, and they were talking about how someone who has a lot of experience in cloud, AWS, said that they bill monthly. AWS does. Azure does the same, I believe. Like they invoice, and of course that depends on your pricing model. Azure does a lot of enterprise service agreements and things like that. But I know with AWS, they were saying that like Netflix, they send the bill to Netflix, and it's a couple of terabytes. The bill alone, just to download, is like a couple of terabytes. So just to give you an idea of all the detail that you get. So yes, they do bill you for everything in significant amount of detail, but they provide you all that detail, and they do give you a lot of ways to manage your costs. Let me go back to that virtual machine and see if it's still incurring compute charges. I think that's sort of like a spinning down state. You can get certain things on your screen to actually show you like the cost. Okay, yeah, it's still spinning down because it started about 736. Yeah, they can charge you for bandwidth, they can charge you for storage, they charge you for compute. Certain objects are free. For example, resource groups, you can create as many resource groups as you want. Other things are not, you know. A public IP address, there's a charge for that. So, you know, however many public IP addresses you provision, you are charged. There's also some charges for traffic. So there's charges for traffic to and from the internet, but there are also charges depending on which regions you use and how you connect the regions. You can be charged for transit traffic as well. So if you're replicating data from, you know, one quote unquote region or data center, Azure calls them regions. Like this one, I think is SCU. South Central US, but they have multiple regions with different features, and they will charge if you're transiting their network to copy data. Yeah, they charge you for that too. So anyway, I hope this was helpful, folks. I got a couple more things to cover as a fun little lab there on BDP. And just a couple updates about streaming. I did install OBS 22 update, and fortunately that fixed the issue with the Streamlabs notifications. So now I'm going to replay one. I got a sub earlier today, and I want to give a shout out and thanks to, let's see if that works. Yeah. So Ryan Eats Reality, thank you very much. Appreciate that. And we also had one the other day that I could not yet acknowledge, and that should play as well. Well, I actually didn't see if it did or not. There we go. Yeah, Ryan Eats Reality, thank you so much for the prime sub. I don't know if you're on right now, but thank you very much. I appreciate it, and I always appreciate the support of the channel. There are some cool new features in OBS 2.2. I definitely recommend an upgrade. It fixed that issue that I was having. And I watched the video that I posted yesterday. It's in yesterday's video. But is really good features about grouping your scenes, which I need to do some work on that. So definitely get the update. I think the next time you run it, it'll actually prompt you to update. I say go for it. Of course, I always recommend you back up. OBS, one feature that I'd like to request is that they have a backup your settings, because if you change something and it screws everything up, it's hard to go back to it. I have a manual process where I basically just back up the folder. It's pretty large, but I wish I'm gonna add that as a feature request, that they add a OBS settings backup, because I have a lot of settings, man. They keep growing by the day. Like, I've got all these. I've got one scene, but I want to create some more scenes. And then I have all these hotkeys that I've worked on. So, yeah, I highly recommend that you back up your system before you do your OBS update, especially if you use it every day like I do. Also, I tried some music features, and YouTube has a bunch of free songs that you can use. I created a playlist for. Awesome stream tonight, man. Definitely had a blast. Good bits and lab every day. Yeah, man. Thank you, mentors. I appreciate that, friend. Thanks for hanging out, folks. Really appreciate it. Yeah, I'm gonna still try the YouTube Music. It says it's free and no copyright, but mentors informed me that he tried to watch the Twitch video, and they, in Twitch video, well, if you save your streams as video and you play music that's not copyright free, they actually mute your audio and they mark it red. So my lips are just there moving, but there's it's all muted. And they did that for the YouTube Music, although the YouTube Music is supposed to be copyright free. But apparently it's only copyright free on YouTube. Like Twitch does not recognize it as copyright free. So I deleted the video. I encourage people, if you're watching, videos of the stream on demand, to watch them on YouTube for now. And I guess I'm going to have to just go to one of these, music services where they allow you to, I've been trying to resist that because I don't like, you have to give it access to your, at least on Twitch, you have to like make it a mod, and it puts a little banner on some of these services, which I don't like, but I may not have a choice if I want to, have the copyright stuff work. So more on that later. Thanks so much for stopping in, folks. Appreciate it. Have a great rest of your night. Sending you good bits, good labs, good study, good streams, and we shall see y'all back here. We'll do it again tomorrow night here on the Land Tamer stream. Have a good night, folks.